Hello and welcome to the lab. I'm going to show you now some of the hardware behind the tools that I was talking about before. How you measure consumption of the resolution that I talked about. So the first thing we have to do is capture the consumption, and we do it in a very similar way to electricity meters. We use current transformers. Current transformers work on the basic principle of electromagnetism, which I'm sure you learned in high school. That is, if you actually pass a current through a wire, it creates a magnetic field about it. Now, if you pass that wire through another coil, this is called a current transformer, pass that wire through here, it creates a magnetic field, and that magnetic field in turn creates a current in this coil. So if we measure that current, we'll find it's proportional to the actual current flowing through the wire that we put through this current transformer. These current transformers are quite cute in that you can actually open them up to snap on a wire without actually cutting the wire. So that's very handy for installation. And you can get current transformers of different sizes depending on the current you want to actually measure. So now we've actually got a signal which is proportional to the current flowing through the wire. We now have to turn that signal into a digital representation. And for that, we have built these digital to analog converters. These are quite specialised. They do a number of things. One of the things they, of course, allow us to do is they allow us to take the readings from multiples of these CTs. So as you can see, this is just one. This particular board can actually sample the signal from 18 CTs, and you can stack these boards as you'll see here, so we can have multiples of 18s, and that enables us to actually do the where part of the resolution problem. We need to be able to actually sample lots and lots of the wires leading out from the distribution boards to know where the actual current's being consumed. This particular board samples this signal a million times a second, so it can actually get a very, very clear indication of the when down to several nanoseconds, and that enables us to actually see, as I showed you with the fridge, we can see how it's using the electricity. So basically, as I say, this actually turns the analog signal from the CT into a digital one, and then that's passed up to a processing module, which then enables the digital reading to be sent over the internet to our databases, and then from our databases we can view them with any number of tools. And in fact, we never actually look at those pieces of data ourselves. We actually have built machines, AIs, to actually look at that data and find patterns in it and find those signatures I was talking about, and analyse those signatures to actually say, well, that's this and that's that, and that's working well and that's not working well, and I'll show you a bit of that later. So basically, this is the sort of thing that would be installed in the customer's premises, in the switch room of your office building or in your cupboard under the stairs. And what we need to do to make this actually send data is we need to give it some memory, and that contains the program to tell it what to do and to where to send it, and of course also enables to buffer the data if it can't get to the database servers. We then need to get the data off of this thing, so we can either use something like a modem that connects to the cellular network, you know, 3G, 4G, 5G network, and send the data over the internet that way. Or in this case, what I'll do is I'll actually just put a Wi-Fi dongle into it, and that will actually use the Wi-Fi in the office to actually send the data that way. So that's it. Let's plug in the CT. And now we have to actually connect this to some load. So down here, excuse me, I have an extension lead plugged into the mains, and I've butchered this extension cable in such a way that I can see the three wires in the cable, the live, the neutral and the earth. And what I'm going to do is I'm going to actually put this CT around one of these conductors. I'll put it around the live, clip it over, done. And now when there's current flowing in this wire, it will create a current in here, and then I can measure that here. So let's switch this thing on. I need to put a power supply into this. Excuse me again. Power into this. This is a very clever board, by the way. What it actually enables us to do is it enables us to actually use the power supply to determine the voltage that we're actually on, and how that varies. And it also actually enables us to actually get the phase, because this is AC, and the more electrically minded among you might actually know that load might actually phase shift from the phase of the voltage, and we can measure that. It's called the true watts. So the last thing we need here is we need a load. So what I'm going to do is I'm going to plug my laptop into this extension lead. Boom, there we go. And now this board is transmitting the consumption of my laptop to our database. So I'll show you what that looks like in a second. Okay, so I've let it run now for a good sort of like half an hour, and I can show you on the screen by switching back to the computer what it all looks like. So let's have a look. Okay, so this is the data that I've been recording for the last half hour. In particular, this little rig has actually been going all night. This was my laptop, as you can see, overnight. It was just sitting there doing a little bit of background processing, picking up emails and so forth. And then about 9 o'clock, if we can zoom in a bit there, you can sort of like see, obviously I came down and started prepping some stuff, getting some stuff ready, so that increased the load. And then as I set up the lab for the video, obviously I unplugged everything, so that's why there's no load between here. And now you can see when I actually plugged it in, and because the laptop had been off for a bit of time, it actually had to recharge back up to 100%, so you can see the charge. And once it had got to 100%, you can see it coming down back to now, where it had gone back to the quiescent of about 10 watts. The wiggles you can see, of course, is the laptop is being used either by me or by the mail program or update programs or various things that are going on in the background. And we can zoom in on that. Now you see that I've actually left this video to a few days before the deadline for creating it, so like a real student. Okay, so there you see the data. So we can look at this data in a number of ways, and as I mentioned, it really is impossible for any human being to look at the quantities of data that we're collecting every second. So we've developed an AI that actually looks at the data for us, and I'm going to show you this in an example using a refrigerator, which I spoke of in the last part of the lecture. So here we have a refrigerator. You might recognise this blue line. I think it was orange in the last thing. And this is the compressor going on, going off, going on, and so forth. And I've superimposed this with the freezer temperature. You can see as the compressor comes on here, the temperature drops down. The minute the compressor turns off, the temperature rises. And so that relationship we teach the AI. In fact, all refrigerators look like this, and you'll see this in a second. This is a pattern that these three refrigerators all exhibit, and it's this pattern here, this number of bars, a bit like almost a chromography display, that the AI can recognise, because the actual wiggly lines are far too variable for it to make any sense of. But by actually taking a second order derivation of the temperature against the consumption, it's able to actually make a fairly good indication of how the freezer is operating. As you can see, even though those three refrigerator squiggly lines, the consumption lines, were quite different, the actual second order patterns bear a striking resemblance. Now, if I take a bad fridge, and you might remember I showed you one before where here the blue line is virtually constantly on apart from the defrost cycles, you can see that while it's on, the temperature barely gets down, and obviously it's not going low enough, it's only going down to minus 16, and it's got to get down further, so that's why the compressor never stops. Now, let's look at the second order pattern of that. And you can notice immediately it's very different, and that's what the AI is actually using. It's using these patterns, and I'll just show you what the good one looked like. You can see a huge difference. Very easy for the AI to actually spot the difference. And so what it can do is it can learn a number of these patterns and relate them to states. So here actually what we have is a period of time going from October to September the next year. And you can see what the AI has done here is it's actually saying, I'm seeing one pattern which has been related to me as good. And so I think this fridge is good. Now it begins to see a different pattern and it's saying, I think this fridge is failing, there's something wrong. And the reason we call this the failing pattern is because this pattern is always seen before another pattern, which is the failed fridge. And let's actually superimpose some of the squiggly lines. So there was the good fridge. Looks a bit different to the one you saw, but again, it's quite normal. The compressor goes on and off and the temperature goes a correspondence. That's what it's seeing, and that was the pattern we saw before, yeah? And that's another one. This one here now looks very similar, but you'll notice actually that the on-off of the compressor has a base on it. It's constantly at 1200 watts. So even though the temperature is going up and down with the compressor, and in fact, from the operator's perspective, they wouldn't know anything was wrong at all because they don't actually, measure the individual consumption of these fridges in most times. So as far as they're concerned, this is working perfectly. But if we look at the second order pattern, see how different it is. So immediately, the AI says, this is a different pattern, and this pattern I relate to failing. I know if it keeps on like that, if it keeps on with the actual heater on the whole time, the compressor's going to fail. And sure enough, after a few months running like that, between January and May, eventually the compressor does give out, and now you can see the compressor's on all the time. Temperature's hardly managed at all. It's all over the place. And so if you take the second order pattern again, completely changed again. It's different from this one, and that pattern, it relates to failed. And so without any human interaction, the AI learns these patterns, and of course we have to tell it what those patterns mean, but once we've done that, it can see them in thousands of devices. So that's it from me. If you'd like to talk about any of those particular subjects I've covered in the last two lectures, please don't hesitate to email me, and I'll try and get back to you as soon as possible. Thank you very much for listening.